Just want to make it clear that I am not an expert when it comes to small electronics. I know my way around pretty good, but you're definitely going to hear me misspeak on different things. So learn as I'm learning. Don't learn from me, learn with me. Enjoy the video. So I have a pretty good setup right here we could use for something. You know, in the last video, you guys saw that I put bullets in here, and tested these tweeters out. They tested out good. And I've got a set of crossovers, which are just for the tweeters. These are tweeters attenuators. What they are to do is provide the cutoff on the low end of the frequency for the tweeters with a variable output. And, that variable output is interesting. So I want to show you in a basic setup how this works. I've got a video up about it to a degree, but I've got another set that I can use for demonstration purposes. Which of these guys that got burned up? They're perfect for demonstration. And also, we're going to be saving some of these components. So, this is a full crossover, okay? Meaning that it is designed for two pieces of gear, a tweeter and a mid-range. And the input is here. So you send your full signal from your speaker to this point. And then it goes through the crossover and comes out on this end. A tweeter output and a mid-range output. This handles all of the frequency attenuation for both the mid-range and the tweeter. So let's look at how this works. First of all, your signal comes in here, positive and negative. And if we flip this over, you can see, let's see, I need a pointer. Good pointer in solar. You can see that the positive and negatives are here. And just by looking at this, I can tell that this side is the negative. And the reason I can tell that is because this trace goes all the way across to the negative output. And the positive outputs are here and here. So on the cord, you can also see this. The negative trace is running over to this point, and the two positives are right here and right here. And on this one, yeah, the tweeter is the orange. So this is the tweeter's positive output, and this is the woofer's positive output. So if we look at what's happening to the signal as it goes through here, we can tell a lot about what's going on. So first of all, here's your positive going in, right? It's going into this little jumper right here. This jumper is essentially a switch. Okay, this is how you attenuate this particular crossover. I showed you the switch on the other one. Well, this is the attenuation for this one. Moving that jumper from one position to the other puts the resistor into the circuit or takes it out. This allows the attenuation of the volume output for the tweeter. So your signal, here's your positives. Okay, so here is the input for the signal right here. And the positive side, again, runs off this way. The negative side runs straight through. The blue is the output for the woofer, and the orange is the output for the tweeter. So the tweeter is attenuated by adjusting the jumpers on these poles. So you got your positive going over here getting attenuated, or it's getting decisions made by going through these poles. And one position brings it around here, brings it through this resistor, brings it out into, let's see, okay, and also, okay, so it brings it through the resistor, and it also brings it through the capacitor. Yeah, and then it continues out. The coil doesn't come into play. Now that is for the tweeter. Yes, I'm making sure, yeah. Yeah, this side is for the tweeter. This side is for the mid-range. So on the mid-range, you'll see that the positive and the negative go straight through. But there's one key thing that's happening down here. And that is the negative side is dealing with this. Let's show it here. So there's a lead that goes from here to here. And I know that this is providing the cutoff for the woofer, but I don't know exactly how. So yeah, input's coming in, ground side here, coils connected here. Okay, then on the tweeter output, the coil's connected here, so the tweeter output's getting an effect from that. Now the woofer, on the other hand, is going straight through, except it's also picking up on this side. I don't know if that's affecting anything or not, though. It's interesting. It's a very simple crossover, but I'm still learning. Well, look how hot this got. The coil got really, really hot. This is melted. It's like a depression right here where it melted into it. Well, the parts that I'm wanting off of these are mainly these capacitors. I could desolder it, probably save a little bit of that leg. But my soldering machine is a piece of crap, so I'm going to nip it. And I'll get enough leg to work with. Capacitors are a thing. They're useful. If you're wanting to create just a basic safety for your tweeter to prevent low frequencies from going through it, this is what you want. It's capacitor. And having a set of these that are the same is kind of handy. Now, this is a resistor. And to be honest, I don't know it's a resistor by looking at it, though I'm learning more and more about these weird resistors. But I know it's a resistor because I understand the basics, the very basics of how crossover networks work. So I know that there's a resistor and a capacitor and a coil. And there's more than one way to use a coil. You can also use a coil in a tweeter-only application, which may be what this is doing. But the capacitor is very specifically the part that it's got a little bit of glue on it, the part that restricts the frequency from going through the tweeter. And the measurements of the capacitor, like this is 100 volts and 4 joules. That determines the frequency cutoff that the capacitor provides. And this is a resistor, like I said. Let's cut that off here. Not much leg to work with, but there's a little bit. I might have to bust out my soldering tools and get better at it. I need a better soldering gun. But we did uncover some interesting details. I know that R1, R is resistor, and it actually gives the measurement on this board. That's handy. 5W, 2R2. And then this is C1, and it tells the measurement of that with 100 volts. And here's the coil, which we're just going to pull off of here. Don't really need a coil. Coils can be made anyway. And it tells the measurements for the coil also. The little screws and plates, you want to hold on to these because a lot of the old amplifiers used this type of wire connections, and it is extremely common for them to be missing on old amplifiers. So when you run across anything that gives you these little screws and plates, hang on to those suckers. I'm going to pull that jumper off of there too, because they may come in handy in the future. I'll get me a little bag and put them all in there. Any and all sizes. And you won't appreciate it until you pull out that old amplifier or buy one off Facebook Marketplace that you get a good deal on, and it ain't got these screws and you're trying to figure out a screw to fit in there. Having those little screws handy is a big deal when it comes to putting it all back together again.